was 1765 when a mathematician named Leonhard Euler proved that in any triangle, 3 points known as the centroid, circumcenter, and orthocenter were collinear and always remained on one given line. Today I'll be teaching you about these 3 points, and I'll also show you what the Euler line is. To find the Euler line, we'll need to learn what the centroid, circumcenter, and orthocenter are. But the very first thing that we need to do is learn what an altitude is. An altitude is defined as a line segment that intersects a side perpendicularly and the opposite vertex. So on screen I have, as you can see, a triangle with the line CB and another line S going through it at 90 degrees. And you can see that if I move the triangle around, it continues to stay at that 90-degree angle that I just mentioned. Even if I make it so that line is off of the triangle, it still is at that 90-degree angle, even if we can't see it here exactly. The next thing we need to learn about is a perpendicular bisector. A perpendicular bisector is defined as a line that divides a segment into 2 equal parts perpendicularly. So as you can see on screen here, we have our line AB, and it's being split in the middle at a 90-degree angle by our line of P. The special thing about a perpendicular bisector is that however I move this triangle around, that will always be at a 90-degree angle. So no matter what I do, you can see that BA is always at a 90-degree angle with segment P. The very last one of these is a median. A median is defined as a line segment that connects the midpoint of a side to the opposite vertex. So right here we have our triangle, and you can see that line I is going through B and is the midpoint of AC. And again, if I move around my triangle, no matter what I do, that will always continue to be in the middle of AC, and it'll always go through point B. Next up is the orthocenter. The orthocenter is part of Euler's line, and it's the intersection of the 3 altitudes in a triangle. Something interesting about the orthocenter is that if I move around the triangle, the orthocenter is able to move out of the area of the triangle. Next up is the circumcenter. The circumcenter is defined as the intersection of the 3 perpendicular bisectors in the triangle. Similarly to the orthocenter, the circumcenter is able to move out of the triangle's area as well. Last but not least is the centroid. The centroid is known as the intersection of 3 medians in a triangle. Something special about the centroid is that no matter how you move the triangle, the centroid will always remain in the area of the triangle. So I'll move it around, and you'll notice that even however crazily I'm moving it, it'll always stay in between the 3 points and inside of the triangle. And finally, we arrive at the Euler line. Now the Euler line is named after the famous Swiss mathematician Euler, who we've been talking about. And Euler noticed that the 3 points that I talked about previously were always collinear, and they always lie on the same straight line. No matter how any triangle is moved around, the centroid, circumcenter, and orthocenter always manage to remain collinear and create what we know of as the Euler line.